I pushed the button.
Push it hard. Push it good. Make it go.
I did. We were doing Arnold Schwarzenegger impersonations off the air.
No, we weren't.
No,
we were trying.
no.
We were not succeeding.
Well, no, it was more about Jim was saying how bad my American Southern accent impersonation was.
Your Joe Brett impersonation.
Well, no, he's just sort of like the catalyst for it. So,
yeah. So it's been a minute. Welcome back to Ham Radio Nonsense, everybody.
Yeah, it has been. I've been away for the last few weeks. Today, I've been able to get onto the stream because of daylight saving. Our regular time, or my regular time, I haven't been able to stream because I've been busy doing other things. But it is 1 hour later here, but it is the same time over there. So I can stream now, which is fantastic.
Ours doesn't change until early November. And here's the weird thing. When yours changes, yours goes 2 hours back from our 1 hour forward, or you go 1 hour in the opposite direction that we go 1 hour in. So there's a 2 hour spread between us.
We go 1 hour forward, you go 1 hour back.
Yes.
And then when we get to winter, when we get to winter and you go to summer, we go the other way and we get closer. It's weird. Yeah. It's all sorts of weird.
Yeah.
But anyway.
And then I'm in Arizona, and Arizona doesn't do daylight wasting time, so I'm already an hour behind all of that. So I think you and I are going to wind up like 3 hours apart at that time.
It's just going to be an absolute nightmare to try and figure out how we're going to work it all out. So, but today what we're going to do is we thought with the whole DI daughterboard stuff that we've been doing. We had been talking about for a few weeks prior to this about doing a K connector for handheld radios like the Baofeng TID radio, all of the stuff that uses the two K connectors.
Or anything that can be easily adapted to K connector, like the UV Pro and the the Vero VR N76. They use an M1 instead of a K1.
Yeah, and I haven't had time to look at the wiring. Oh, here he is. He's back.
He's back.
We were just doing bad impersonations.
Okay. Good eye, mate.
Yeah, see? Like that.
Like that.
By the way, who's that behind you on the on your left side?
Yorick.
That is Yorick. Not Yorick, it's Yorick.
Yorick.
No, it's Yorick. Yorick.
Was he on...
That's what I said, Yorick.
Was he on car?
Rick?
On
car? Yes, he still is on car.
He's still on car.
I 3D printed this.
That's 3D printed?
Yes, it is. For desk tchotchke at work since it's Halloween.
That's cool. That is, I would not have picked that was 3D printed. That is very nice.
Well, the camera hides some of it.
It does, yeah.
Well, it's still a really good print, but
it is a really good print.
How big's your printer?
The only place you can see really, and I don't know how well it'll show up on camera, there's layer lines as it went around the curve at the top of the skull. But other than that, it's smooth as a bear skull.
Baby's bottom.
I don't know. I've never seen a baby's bottom, but I have seen bear skulls.
You have a baby.
Yeah, you're a father, aren't you?
And you've seen her bottom.
Well, yeah, but that was like 14 years ago, and I was too busy being traumatized by the green mess that was coming out of the demon that I had created.
There is nothing about childbirth that isn't traumatizing for both parties involved. All three parties involved, actually.
I was pretty freaking traumatized. It's like, oh my God, put it back. It's not cooked.
So what we're going to move on to now. Actually,
please.
Yes, we better definitely do that. We were going to do some design work today. This is just completely us having a bit of a play around on the PCB software and seeing how we go with designing something. We're not sure whether it'll be useful or not, but what we're going to do is very, very basic, a board which will use the 6-pin mini DIN to the K connector. So we're going to play around with easy EDA and see how we go. Yeah. Now, the other thing that we got to do is we've got to plug where we get the actual boards from.
We do. So, yes, you do get them from TO, from temporarylyoffline.com if you're in the U.S., and this also covers Canada at this point. So that way you can deal with local shipping instead of overseas shipping. You can get your DI board, which is the interface to go into the computer, and you can get your DB6 if you don't feel like prototyping. If you hover over the DI, you can see the breadboard. the other one. There we go. You can see the breadboard work that you can do if you are so inclined. The whole point of this is a tinkering project, so you can get older radios that don't have a USB sound interface onto digital modes like FT8 or WinLink or APRS. If you are in VK land, we have another website you can get them to with local shipping as well, and this also works for ZL land. And Hayden's got the AIOC there for sale as well. And then if you are, I don't know if you have Jonathan's site up here. If you're in Europe,
I can bring that up.
You can get them from our buddy Jonathan M0JSX. And
all the links
this will
are
get
in
you
the
all
description
local
below.
shipping. Yeah. And we forced him to build this shop just for you.
We did.
Yeah.
We did.
And then if you go back to Hayden's website, Hayden's got some really interesting shirts and sweatshirts and desk mats and wall art and stickers.
I got some Shack gear, some new stickers, some...
Oh, look at those Wagos.
Shirts. Yes, I've got some Wagos as well.
Those are
the newest one,
handmade.
which this one's been a little bit popular recently. Yeah, made famous. Is
as seen on Facebook.
Yes. So if you want to get yourself a funny shirt, which you can show off
better
at
than
any
Netflix
Handfest.
too.
Yeah, well, that's probably going to be the next iteration,
right?
So no one steal my idea now that you've just. Well, it's actually your idea, I suppose.
Yeah. I need to do shirts. Those.
Well, we were talking about this morning, Jim. You need those Columbia cornflower blue shirts with FEP Labs logo on them.
Right. But I'm afraid that they would be too expensive for most of our people, because as a people, hams are kind of on the cheap side. I mean, you're only selling T-shirts, right?
Actually, I will correct you on that, and not pedantically at all. It's only the cheap hams that are loud and vocal. That's why we know about them. The wealthy hams, they don't complain one bit.
Now,
fair.
I've definitely... Yes, that's... Well, Liberty, you get at least 5 dB using these shirts. But the other thing is... I have upgraded my store, and if you go up to the top right-hand corner here, let me plus that bad boy up so that you can actually see that.
Plus that up, son.
Look at that. Over here, you can change to whatever country you're in. These are the countries that currently are showing at the moment. More to come.
Yeah, because Aussie prices are kind of shocking to US people's.
Right. So click on USD, and then I think we might just have to refresh the page. There we go.
There you go. Look at that. You just saved $8.
You've got the price.
Oh, hell, I thought you wanted real money for these. I'll be buying 3 or 4 of these now.
Yeah. Look at that. You could look like her. You could get her and him shirts.
Yeah.
I think it's absolutely hilarious.
My wife would totally wear that.
Yeah, I bet she would. And then if you go back over to my store and you scroll down, you'll see a couple of things there. And I got to do a quick announcement. So I've got shirts and sweatshirts and mugs and tumblers and notebooks and stickers and stuff. But if you go down one more tier, you'll see the bespoke Ziggy chokes. And these are built to order when you order them. So don't expect to order it today and get it by Wednesday. This ain't Prime. So Ziggy's got to build these by hand when you order them.
What is that background?
It's a 75 ohm ham desk mat. Yeah.
Oh, it looks like he was summoning a demon or something with that. I wasn't sure.
Well, he is. He's asking for 75 ohms.
Well,
when it's
do you see how the demon's not going past the choke? So it's working.
Right. I guess so.
Shipping and handling is nice and cheap. It's all done usually in the US, so you can go and check those
The shirts
out.
are local. They're printed on demand and then they're shipped locally.
Now you've undercut me by $6 here. You're
I did
$15.50 there for the TO shirt. So
yep.
But yes, we wanted to plug some merch before we go into Easy EDA. So we're going to call this the Toads DIK.
This is not the official DIK though. We could call this the fake DIK.
Do we want to call this the fake DIK? Do we?
Because we will have a DIK eventually, which looks like the DI6, but instead of having the 6-pin, it has all the logic on it and the K connector.
So you should take a step back for a minute. So JLC PCB, who do PCB stuff out of China, have this free PCB design software which integrates in with their particular line of assembly components. And they've actually got the Pro Edition, which is completely free now. So that's what I've been using. You can import KiCad stuff into here as well. But I just use the free software. So I guess the first thing is let's go in and we'll create a new project. Then we'll call this the fake DIK board.
So many jokes.
And not enough time to make them.
No, I respect you too much.
We got to get past the 8-minute mark. Oh, we are past the 8-minute mark. Go ahead.
Yeah, we're good. We're good. Who else is in the chat? All I can see is Liberty Cave messages.
What is that?
Yeah, it looks like he's having a stroke too.
I'm not seeing many in the chat. It's pretty quiet. The chat is quiet.
People are just not used to me streaming again.
LC, blink your eyes if you're okay, or if we need to call 911.
So what we've done here is the problem is when you plus it up, everything.
Can we back up? What is DIK, Digital Interface Kenwood? Is that what that?
Yes.
Stands
yes, for the K.
Will eventually
for the K
be.
connector.
Yeah, okay. Yeah. That's what I thought.
And we've got a couple of other designs in mind, like the DI, I don't know, the DI13, because there's a 13-pin connector for Kenwood. There's a separate 13-pin connector for Kenwood, and then there's a 13-pin connector for ICOM. And then there's a 10-pin connector for Yaesu. Like Yaesu has 2 different standards, ICOM has 2 different standards, and Kenwood couldn't be, left out of this. So Kenwood has 3 different standards. They've got the 6, the 13, and the 13.
I find it amusing that you call these multiple standards standard, right? Big air quotes on that. You hear us, big radio? Bunch of yo-yos.
Yeah.
Very big.
Center on USB-C for now.
Right.
Okay,
I don't mean USB-C shape. I mean real USB-C.
Go and ka-chunk the keyboard in the chat because I'm a bit worried we've got 60 bots in the house or something like that. So what I've done is I've just renamed on the left here. Let's see if we can do this. It might make it a little bit easier to see. On the left here, we've got our sort of project structure. So here's the first board that we're creating. We're only creating one board. It's going to be very simple. And we've got the first page because we're only going to have one page. And we've got the PCB layout here. So this is the schematic, which we're looking at the moment. So this is where we're going to draw our circuit. And once we've drawn our circuit, we can open up our PCB layout here, which is showing nothing because we don't have anything at the moment. We can then place our parts basically on our PCB. So we'll see how far we get in today onto this. And I'm still learning this, so it's a bit of a work in progress. So I guess the first thing that we want to do is we want to import in the 6-pin mini DIN, right? That's what we want to do.
Yes.
So along the top here, and because I'm sharing a window, you don't see the drop downs. So let me just fix that and share the entire screen instead, which should fix it, hopefully. Does that not show drop downs? No, it does now. So you can select components, basic things like resistors, capacitors, inductors, blah, 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 all along the top here. You can put text in. You can hover over all this stuff to find out what it is if you want to play with it a little bit later on. So if we click on component, this brings up like a component search tool where you can view all sorts of different components. Here's some op amps and stuff like that. And the one you want to look for here is JLC PCB stock. This will tell you how much stock of the particular component they have. Now, this is very annoying to try and search through and find stuff in this filter view. It's not sort of the best. The best way is to go to JLC PCB/parts, which is up here in the top left-hand corner. And then you can search by the part here. So you can put in 6-pin mini DIN. We can do a search.
Bobo said something that's either very clever or he's having a stroke, and I'm not sure which.
He's answering a previous question from Sean.
You need the footprints of the parts before you start rat lining. That sounds like insider talk or something.
Yeah. So Sean said it starts with placing parts before drawing the logic schematics. Yeah. So you have to start somewhere. So basically what you do is you put the part on, which gives you all the different pins. Like a resistor has 2 pins in and out. And then from there you can draw the rest of the schematic. And
that's
so this
what
is
rat lining means.
Let me show you an example here. So here's some drawings existing, which I'm just showing you the process. We'll probably end up just copying and pasting this because it's easier to do. But you can see here that this is one of the mini DIN connectors here with all of the pinouts and the pins. I don't place parts down on the schematic on the PCB. I put them down on the schematic first. You draw out the schematic and then you lay out the PCB. So if you actually double click on this particular part, you'll see here all of the. Now, the other thing I should say about Easy EDA is it is a little bit janky because it's like a Chinese website that is a little bit slow in some places. It's probably not as good as KiCad on desktop. So by all means, use KiCad if you want to use that. But it works in most cases. So you could see here that here's the device, DIN 603, and it's got all of the part numbers and everything. And this, it auto-populates the footprint and auto-populates the part in when you select it. So if we go into here, you'll see DIN 603. There it is. There's the 6-pin mini DIN. They've got 810 in stock. Here's another one, which is similar, I think. So yes, putting the parts down on the schematic first and wiring everything up before you go laying out the parts on the PCB is the way to go. If that makes sense. So yes, so 6-pin mini DIN. So their search is a bit funny. So like I searched for a mini DIN and it's got these big DIN connectors, which we don't want. So you kind of have to like go through here and try and find, like there's our one I think that we're looking for. But you kind of have to drill down a little bit further and see if you can find stuff. There's filters and things that you can use. Like there's 300 and something thousand parts here that it's found. So you can really drill down.
358 bloody thousand parts. You got to do the full-on Aussie accent.
That wasn't Aussie that you did. What was that?
No, it wasn't. It wasn't. It was a mess.
It was like
absolutely
British
crazy.
I gave up trying halfway through.
John says no audio at the moment. What's
he
for
means
him with the wife?
He means him. Yeah.
And then it's all that other stuff. Look, Mike, that might be the case, but hey, we're no. Basically, we don't give a shit, to be quite honest. So,
yeah,
if they want to make this, they can make this. So, I think this was our part number anyway. It's either this one or the other one.
DIN-603.
Yeah, they do have so there's a manufacturer part number, and then there's also a JLC PCB number. Now, you'll see that this is a Hooyah.
Hooyah!
But then this one here is a Legion. So it's got a different part number, like JLC PCB part number, but it's got the same manufacturer part number. So this is where you're going to go into the data sheet. So let's open up the data sheet for that one and open up the data sheet for this one. And then you've got to like compare the two. Now, this is where I came unstuck when I looked at the different data sheets between these for building the digital interface, the Daughterboard, because what had happened is the pins weren't how I thought they were, because you could see here the pinouts are not actually very well defined on the data sheet. So you kind of have to do a lot of research to try and find out what pin is actually what and where it goes to on the particular schematic. Because when we go to wire this up, this is where it matters, because all of a sudden we could be miswiring things.
And this is why this process gets to be expensive, because you've got to do this design work. Then you've got to outsource the actual creation of the PCB, which costs money. Then you have to wait for shipping, which costs money. Then you have to plug it in, which might fry something, which costs money. So
I think when we made the DI 6, that probably took a good... Well, I had to learn Easy EDA along the way, but I reckon that one took probably a good, I don't know, 10, 15 hours or something to try and get that built up. And that's a reasonably straightforward, easy circuit. So rather than searching through all the parts again, because we know which one we want, let's just use the one that we use on the digital interface, which is this one. This is the JLC PCB part number. So I'm going to take that and then I'm going to paste that in here on the fake DIK board, and it finds it straight away. So then I can just go place.
When you ask for it by name, it comes back pretty quick.
And there we go. I can just place it onto my PCB, onto my schematic. So now what we could do is we can wire this up to what we want. So if we go back over here, you'll see that all of these pins have what they call nets on them. So a net is basically a way of wiring this schematic without drawing a physical wire between the two. So for instance, here, PTT on pin 2 of U1 goes to PTT here on this particular circuit.
And the software knows behind the scenes to draw that wire.
Right. Because when you go into the PCB later on, once this loads, that's when you can go in here and it will draw lines where you need to draw the tracks between each component.
Oh, so it does that automatically. You didn't have to do the traces.
No, so you can do auto routing. So if you go up to, I think it's auto routing, it will draw all the tracks for you. But it does some weird stuff. Like some of the tracks are all over the place. And like, hey, if you don't really care and it's a really simple circuit, then it's fine. But this one, whilst it was reasonably simple, it did some weird stuff. Like, for instance, this track here, it wouldn't draw it between these two resistors here and then to there. It would go like around here and then round there and then up and then round. And it just did all sorts of weird stuff.
Okay.
So what I usually do is I do the auto routing and then I'll go in and fix everything up. And just go through it. Yeah. Now, this is a multi-layer board too. So this is top layer is the tracks on the top layer that you can see there in green that I'm toggling on and off. You've got the silk screen layer, which is just the printed text on the top of the board.
The white stuff, yeah.
Yep. You've got the solder mask layer, which basically is all the pads that all the components go on. So you can toggle that on and off as well. There's also a bottom layer. So the bottom layer is just one big copper ground plane that you can see. So you toggle that off. You've got a bottom silk screen layer. So that's just text on the bottom as well. And then there's all sorts of different layers that you've got here. So, but they're the main ones that you work with. This software is also pretty cool too, because you can actually view a 3D view of your PCB.
Oh, that's kind of cool. And
you can see what it looks like. Gives you some sort of indication about, how things are going to go. So this is the bottom layer that we've got here, and this is the top. So this is essentially what you get when you get a daughterboard. Bobo's auto routing. Talking about auto routing, it's
it's an art.
It's good, but so just a bit of context. I used to make PCBs and design PCBs like over 15 years ago. Pretty much daily. And it took me a little while to try and relearn what I used to do. And this is by far not my best effort whatsoever. But it is pretty cool to be able to, breadboard stuff up like what you did, T.O., with the pins.
Yep.
And then once you breadboard everything up, then you can actually make it and get it built.
Yeah, so don't let perfect be the enemy of good. Make something because it's part of the learning process. You're not going to get to perfect until you've failed a couple 100 times.
Yeah. Yeah, like, for instance, I made this and I chose all the parts out and try and figured it all out. And then we found out that LED 1, which is this green LED, was like super, super bright, like almost as bright as TO's LEDs in the background there. It was almost like that's if you had a DI interface board on, that's how bright it would be. So it was like, oh, it's not perfect, but that's fine. Just use a little Sharpie or something to just dim it down, and it was fine. So what we want to do is we want to I'm basically, I think what I can do is I think I can do this. I can copy this, and then I can go over here. Actually, I won't delete that out. I'll just paste it. Can I paste it? Pretty sure I can. Yeah, look at that.
There you go.
Boss.
And now all your nets are labeled, so you don't have to do
Right.
that a second time.
Right. So because I just wanted to show the process of how to add a part. So now we need 3.5 millimeter jacks is what we need for the K connectors, right? That's what we're going to go with.
One 3.5 and one 2.5. Yep.
Now, are they stereo? They're stereo, aren't they?
TRS.
TRS. Let's see if we can find something that's suitable. A lot of them have. See, look, now it's doing weird stuff, like it's showing chips. So what we need to do is we need to go into here and go their connectors. Circular connectors, maybe. Apply that filter.
Or stereo connectors.
That's not right.
Yeah, try stereo.
Maybe I'll just take TRS off.
Or just try TR. Well, I was going to say try TRS.
Okay. So TRS... I need to scroll down a bit and we might be able to find it. Actually, if we put connector.
Yeah, this is the part that gets me, is trying to weed out what part is the right part.
Well, the thing is because they've got like literally millions of parts.
Mm-hmm.
And I mean, their search is not very good, obviously. Assuming they've even got them as well. Like we don't even know.
Tommy, I don't know if we're going to get far enough to. This is more of a tutorial on how to use Easy EDA. But if you find value in this when we're done the process, then yeah, we can make it available. But right now, it's just going to be a media converter from 6-pin to K connector.
Right. So the original idea was we were going to do we were basically going to just have this board and just swap this connector out here. But we just wanted to have a bit of a play around and demonstrate.
Yeah. Teach y'all something. Get your brains working.
Well, I'm still learning as well. Like I'm trying to learn how to find the damn plugs.
That is a pretty lame search on that website, I got to say.
Oh, it's
overwhelming.
It is. But that's the other thing, though, you got to try and remember is there's millions of components.
Yeah, but I mean, you've searched for
audio
TRS
interface?
and 3. Yeah, try that one.
You just passed it.
Audio jacks.
Oh, here. Where was that? Oh, audio interface ICs. It's not an IC. So let's go back then. Let's go back to all components. Let's get rid of that search. And if we go down here and we go to connectors, here we go. Let's go
audio connectors. There we go.
There we go.
Yeah, look at that. It's
It's like the first one.
Bob's your uncle.
See, that one's too wide. We got to get the next one down, which is more narrow. And then there'll be room on the board.
So let's open up this one and just double check that it is stereo and it has all of the components that we want. Now, there are different components. So you can see this has got extended. So there's basic components and extended components. So the extended components mean that they have to physically change the reel. They've got, in the factories, they've got all of these reels that are all their most used components, basically. If you get an extended component, they have to pull the reel off and put this reel of these components on to be able to populate your particular board. So there is a little bit of a surcharge every time they do that. So if you build a board up, just have a look and see if you can find as many components that are basic as possible. For these, most of these will be all extended because they just don't have them on the reel. So
I see TRS. I see 3 pins.
You see 3 pins. Let's open up the data sheet and have a quick squiz. 1, 2, 3. There we go. Well, actually, it's 3, 2, 4. Now, this is the other thing is...
I assume that they're wired the same on all those.
Well, that's
on
the
all
thing.
the K connector radios. Yeah, it's not a K connector if it's not a K connector. You know?
Well, no. I meant on your 3.5. Like the sleeve is always the ground.
For 3.5 millimeter audio, yeah, but this is a radio. So the sleeve is the mic data, and the ring is the mic plus, and the tip is voltage.
Okay. Well, the same question applies though.
Yeah. So three.
It's okay.
So three looks like that's the sleeve, right?
Yep.
2's the tip and 4's the ring. I think 2's.
So I just shared out my screen. There we go. Restream just put me up straight up. So there's the pinout of, so it's using 3.5 millimeter plugs, but it's not using the audio standard. It's to answer Jim's question.
But we still need to wire it the same way. So you got tip, ring, sleeve.
Yeah, we need to wire it K style.
Yeah. So when we go to the data sheet, we just have to make sure that we know what pins go where. So if I just, if I can maximize mine up again.
And Bricker has a question. He wants to know why not revive the AIOC design and swap this in and flip the connector around so it's coming out the bottom, or go dual-sided.
You can do that.
Shrink the design.
Because it's a completely different product. AIOC is fantastic. Simon is awesome. Simon's in the Toads Discord with us. Mm-hmm. And Simon and I talked a day or so ago in the AIOC room, I think it is, where somebody asked what's the main difference. So, I mean, the answer is you could revive the AIOC design. It's open source. You can modify it however you want, but this is something different than that. The AIOC uses an STM32 microprocessor, and then it does serial programming control and sound CM108 emulation. Now he's just added that. So, yeah.
So I've placed the component, and I mentioned this before. So it's actually imported the footprint. So it's got left, right, ground. So awesome. We've got 324. If you have a look at the data sheet, if I get the right one, we don't need that one anymore. 324 here, and on the bottom you've got 324 on the pins, so we know exactly where it's going to be all wired up, which is really good. So now we just need the 2.5 millimeter version of this. So what I want to do is I can put in, or we could go searching down through here. There's one, but that's a different part. So usually what I want to do is we could go in here rather than looking.
And see if you can find a Boom LE 2.5.
Something that's similar, yeah. So if I tick this, that's a Boom LE, and there's only 5 results. So let's just go view similar and see what comes up. 3.5, 3.5, that's the one that we picked. 3.5, 3.5. Okay, so there's only 3.5 in that sort of size from Boom LE, which is fine. So what we can do is we can go back now and audio connector. If we scroll up, see how we got 2.5 millimeter headphone. If I click on that, and then go apply.
There are some STLs, John, in the Discord, in the Toads DI room. We didn't create them. I think Chris actually made one, and then I can't remember the other guy's name. I want to say it's another Steve. And then Jim printed some for me. So,
hey, I like these rather than having the through hole mount.
SMT.
Yeah, maybe we should try and find a couple of those.
So there's a minor concern with that. Some of y'all are not gentle. Some of you guys don't have mechanical empathy, and those come off the board if you're not gentle.
Speaking for old people with sketchy eyes, the through
you represent a large population.
I do.
Jim.
I do. I represent a large swath of the entire amateur radio community. The through hole ones are a lot easier to get mounted.
And I could say that because my eyes are getting worse.
Welcome to 40.
Well, I'm not 40 yet, but which
doesn't
is
matter. Welcome to it.
Right. That's the other thing is that if you get these particular boards made up, they'll actually populate all of the components for you too. So you don't have to if you don't want to.
Right.
What are
you guys are open sourcing this too, right?
No.
No? Okay. I didn't know.
This is about
learning.
This is just us playing around.
Yeah.
Well, I know that's what this is. I didn't know if we were. Never mind.
Jim's giving away our trade secrets.
Right.
So
we're gonna sue Jim.
I also like searching by stock, because if you're going to be making a few of these, you want to make sure they got stock as well. So let's go plug in. Oh, look, there's 21. Most of them are surface mount. Maybe that one or that one.
Can you, I mean, to me, it would make the most sense to take the one that we got for the 3.5 and look for the same manufacturer.
We already did that.
Okay. Then they don't
You
have
weren't paying attention.
No, I was busy interfacing with the chat.
Yeah. No, we already
I have my job. You have your
chat.
job.
So in here, when we clicked view similar, there was only like 5 and they were all 3.5.
Okay.
We could do it the other way though.
Was. All right.
We could find a 2.5 and then try and do the same that way. So let's use this one.
And Zfall is saying, couldn't you just put a Bluetooth chip in there? We sure could, but that's not tonight's exercise. That's a future exercise.
That's a whole nother show.
It's definitely on the planning list.
That's, and I'm going to need some help for that.
I have some ideas.
Okay, so this is a 2.5 mil, but this has got 4 pins. 2 of those pins are connected. Is that right? Different models. PJ 2100 CB, PJ 2100 B4A, B4A. So I don't think we want the 4-pin one, do we?
No. We
want the 3-pinner. So this is, it can get a little bit. This is where you waste a lot of your time, is just trying to find parts. Jim's getting all sorts of ideas now, I reckon.
No, I'm just being attentive.
Is this another 4-pin one? What if I'm not sure if we can use this or not. I think 2 of the pins are joined together.
Right, yeah.
Housing is pin 1, so shield. 2 is axle sleeve, terminal. Just go back to your design, your pin out. We only have 3 on there, don't we?
Yeah, it's 3 and 3. TRS.
Okay. And this is what, TRRS, is that right?
Yes, because you have 4 pins.
Yeah, which we don't want. How can I... Just seeing if we could break this down rather than having to look through every one. I gather the 4... there's a 204.
What's the second one from the bottom?
Second one from the bottom, this one.
Yeah, that one. That looks like 4 pins, but I can't tell.
I think that is 4 pins. Let's have a look. Yep, 4 pins.
I like it, Elsie. As soon as you do something, someone will tell you what you should have done instead. Exactly.
We're waiting.
I came up with this. Yeah, I know.
We're
Come
waiting.
on, get to work, Elsie.
Yeah,
Hayden and I came up with this a couple years ago at Dayton. People will raise their hand to have a question, and their question is basically, I did it this way. Why didn't you do it my way?
Yeah.
Here we go.
They should you.
That's great, but what do you think about using a 17-foot whip instead of a 20-foot telescopic fiberglass mast and a piece of wire?
I don't.
And basically what they're saying is, I did it my way. Why didn't you do it my way also? Because I did it my way and not your way.
I don't know that I fully agree with that. I don't think you're completely wrong, but I think part of it might be validation, because if you're speaking somewhere, you have that authority, right? Even though I know you, but people would be like, oh, T.O. said what I did was going to work fine.
It will.
Maybe.
Everything works. RF going to RF.
Right. We stole that from Ziggy. You stole that from Ziggy. I stole it from you.
I did.
At least you
the associative principle. Oh, for sure.
So we've got the 3.5mm jack. So I'm going to put some text in now.
RF will find a way.
Right.
The RFs.
There's getting to be too many movies made now. It's hard to do movie quotes.
What? No. Easy.
There's so many
Good
movies
movies.
out that the what do they call it? The Venn diagram of the movies you've seen, the movies Hayden's seen, and the movies I've seen. The overlapping center part isn't that. It's not that full anymore.
Well, I would point out two things. Number one, Hayden got that because he chuckled right away, and number two, you're explaining the gag, Ham. So,
yes.
Thanks.
All right. While you guys bicker.
I'm not bickering.
That's what we're here for.
We're being pedantic.
So what I'm going to do is I'm going to draw a wire, and I'm going to draw it from the ground here. And I'm just going to draw it out. And then we'll do the same on this one.
You're making the nets now? Or you're just connecting them?
I'm just going to connect those two together. And by all means, don't copy what I'm doing because this is probably not what I would really do. But I'm just basically showing now those two pins are connected to ground, right? So now we need to wire up our pins. And this is where TO comes in.
Sure.
So our first one is the 3.5mm jack. And that is the tip, I think, which is the right. Let me have a look. It's TRS connector. Why is my monitor not on? TRS connector pin on the right.
Oh, Jason's here making fun of your accent. We can make fun of his Texas accent now.
Draw it out.
He said solder earlier too. I let that one slide.
Solder. Okay, so I've got an image here which is showing me that ring on a TRS connector is right channel.
Yep.
And that is showing right as pin 2 over here. So is that ring? I guess that's ring, and that's tip then.
Probably.
All right. So let's go with that. So can you bring up the diagram, the wiring diagram that we need?
I've got it on my screen, so you can draw it on yours. You want me to share it out so everybody can see it?
Well, I need to see it. I don't know what the hell I'm drawing.
I sent it to you in private. I don't know how many screens you've got over there.
Too many. Far out. Where is it?
Discord.
Did you send it on Discord, did you? Oh, okay. That's why.
It's the same picture I have. I can just, read it to you. But we've got limited space for the stream.
Just bring it up anyway, just to show.
Okay. Ta-da!
Right. So the ring we have, is that mic plus? So audio? Mic plus audio?
Yes.
Okay. So let's go back to here. We'll keep your share going. Oh, how did I get rid of you guys? That was weird.
Just drag it. Let me do it. Ta-da!
Yeah, there we go. It's hard to be a producer and everything else at the same time. So
I'm here for you, bro.
I reckon we get rid of RX 9600 because that's the 9600 audio coming out of the.
Yeah, the Baofeng can't do it.
Yeah, let's not do that.
The Quanchang can do it if you rewire the Quanchang, but this is not that kind of project.
And we don't have squelch, so we don't need that either because most radios don't output that either, like the Baofengs and stuff. So that leaves us with these three. So RX 1200, that's our audio, our microphone audio. So that's going to go to here. So what we do is we create a net label, and we'll just bring it out here. And we'll call that RX _ 1200, which I think that's what that's called. I think somewhere, I'm not entirely sure where, you can actually select the nets from somewhere.
Freddie, I'm going to send you a bill for that one. Oh, never mind. I get it. I get the joke.
I was processing. I was like, what the hell are you talking about?
Actually, that's not what I want.
Slap that like it didn't make you the sandwich you asked it to.
Let's not do that. Let's do this. So let's select, if I can, that net label. And then we can avoid any mistakes that we might make.
And Bricker is offering a lot of advice here in the chat.
That's good.
He thinks
What's saying?
You don't want to connect those grounds. That could be bad.
Why?
Where do they connect to on the backside?
Just go to our I'm not
arguing with you.
Actually, just go to our schematic. Oh, I can do that, can't I? He might be right.
And he also said you should put a filter circuit on that because common mode is a thing. Put that on the ground.
Look, we're not making a filter. We're just making a direct interface. That's all we're making. We're
making a glorified cable, like you were talking about doing earlier.
So this has got mic negative, receive data, and PTT on that side, and then we've got speaker, PTT, ground data on there. So he's probably. This is not a very good drawing, but yes, I think he might possibly be right there.
See if I can find another one.
So let's do that then. Now, ground has to be on one of them, which data, ground, receive data, ground everything. So we've drawn that one. Let's now go speaker. I'm assuming speaker plus is the audio out. So we've got, this is mic in and this is speaker out, I'm assuming. So that's going to be our microphone. So we need to take, for goodness sake, that. And
so when you create those nets,
yep,
by naming them, that ties it to the other net that has the same name, or to any other net that has the same name.
Yep.
Okay.
If you actually click on it, you'll see that it's got a line to indicate that is to there, and then anything else that's also named the same will be like that.
Will automatically connect. Okay.
So if I go into PCB, and we haven't even drawn our board yet, but if I go import the changes from the schematic, and it will say, please add these components. I go apply. Yep. Here's our components that it's drawn. And see how it's drawn the lines?
Okay. Yeah.
Between the pins.
That made sense, but I've never done this before, so I was...
Yeah. But yeah, that's right. So essentially what we would do is we'd do something like this. Let's put that on the bottom. We can draw the board around it later. And then what we can do is then we can draw our tracks, between our components like so.
Okay.
And then you hover over that and you can see those two are joined.
Cool.
But it's the wiring that's the problem at the moment. This diagram's throwing me off a little bit. Hank, if you can find us a diagram that we can follow, that would be fantastic. Because then we can follow the correct wiring standards. There's that word again.
And with an American accent, that was awesome.
Let me see if that wasn't meant to be with an American accent.
Yeah, I looked at a bunch of other ones, and they say the same thing that this one does. They just have exponentially more crap on the same picture.
Yeah, okay. That might help, though. What about this one? Let me plus that one up. Is that one any different? So you've got speaker, so that's fine. You got speaker there.
It's the same picture. They just added more stuff to it.
Mm-hmm.
Yeah, but
it shows the connections.
So we got ground here on this side, and then this will be the PTT line there because you've got that switch. You've got the microphone there, V plus, and speaker. Yeah, so this might work a little bit better potentially. Let me send you that link, Tio, so that then you can bring that up.
Okay.
On your side of things, so I can go back over here.
Hank, shoot it to me and I can bring it up here.
Yeah, then that'd be good. Jim can share that out. Okay, so we have...
So all the talk about grounds, and they're not even connected in the audio circuit.
Only one is on one side, yeah.
So that's to worry about.
That's on the sleeve of the 2.5 mil. So we can put ground back on there, which is good. Now, how did we go? It was sleeve, ring, tip at the bottom. Is that right?
You found a thing that said what right and left audio was.
Right.
So maybe once you get back to that page, you can rename those things to, tip, ring, and sleeve.
Yeah, so let's do that now. So let's go. So,
yeah, John McClure, he's a genius. He knows a lot. He's a smart man. He's a smart feller.
So those are also pin names as well. So I generally don't like changing those because it can mess up things. But what we can do is we can just put in some text and we can go tip.
Okay.
Or we can go.
What schematic is this?
This is the one that Hank sent me, I assume, for the AIOC.
Tip. Ring.
So Jim's sharing out his screen right now, Hayden.
Yeah, it's all right.
I thought you guys wanted it. I can unshare it.
No, I'm just copying stuff, so it's fine. Let's do that. Move this net in a bit more. Okay, cool. So we've got sleeve there. We've got the tip. So the tip's going to V plus on there. So that's wrong. So we need the ring of the mic going there. So that means we need to move this down. Take that out. Take that out. Cool. And then we've got... I hope you can understand what I'm playing around with and what I'm doing.
Yeah. Right now you're trying to label the pins and connect them all where they should be connected.
Yeah, they were just around the wrong way, just with the understanding of that particular earlier diagram, which wasn't in there. So, okay, we got that. Now we need PTT. Let me move that in so that it's a little bit neater. PTT, which is the sleeve connection. So they also add PTT onto the mic ground as well. So when you ground the radio to transmit, it also grounds the microphone as well, which is really annoying. That's fine.
For receive. So it wants to silence the receive on the microphone.
Mm-hmm.
Interesting.
Which is, we don't use it at all, so... Right, I think that's right. So we've got PTT going to... Can we do split screen? I think we can.
And try that.
Yeah.
Put that down there and that down there.
Yep. And then I'll just plus this up so you can see. Hopefully see.
Which you can do with a 1920 by 1080 screen and make it really hard.
Very limited. Okay, so we've got PTT goes to the no, that's wrong. We need to go to the sleeve. Oops. There we go. That's better. Right, which is labeled as ground. So we've got PTT, which goes to the sleeve. We've got pin 2, which is the tip going to V+, which we don't need. We've got the RX 1200, which we probably should rename, but
yeah, that's the AOC page.
Says that's the mic, because that's our audio coming in from the... No, that's the other way around, isn't it? Because we're doing radio. Because we got... This is the thing, is it takes a little bit of time to actually draw all of this stuff out to get it all right. Because that's going to be our speaker audio. And that's in and that's out. I think that's the other way around. I'll have to have a look on here. RX 1200 goes in via our other audio switch. Yep, receiver audio. So if we just swap this around, this is riveting stuff, watching me just play with buttons. And
we got to learn somehow, man.
Well, are you learning, or is this just not making any sense at all?
I'm learning something, but I mean, is anybody else learning something?
I'm learning something.
B-Mad says your shop is sold out of boards. Which shop?
I'm learning something. I'm learning I would pay people to do this.
That's why you buy pre-built products. Yeah, W5TTX is asking about a recap. So what we're doing is we're trying to tutorial our way, explain our way, learn our way together through using easy EDA. And we're essentially making a 6-pin cable to Baofeng K connector cable adapter to make this really easy to plug our existing products into your K connector style radios. But really, it's just a tutorial. This is maybe not going to wind up being a product, or maybe it is if y'all want it. Who knows? Because there's probably a lot of reasons for that. The USA shop, that's my shop. Let's see what's going on over there.
What the hell?
You sold out. It. You got none left.
I'm checking.
So
Shopify's
now
I
think we've drawn everything out there. So now what we can do is we can just rough that in. And everything is just... Let's just draw a board outline.
Oh, got one left in stock? Holy moly. Good thing I ordered some more. Looks like we are out of stock.
Yeah.
Unless you're in Oz or Great Britain.
I've got some
stock
still
left.
there
it is. I've got 12 committed that haven't been shipped out of 19 total. So that leaves 7 available. And then the digital interface itself, I've got 0 available.
What storefront are you using? Are you using Shopify?
Shopify, yeah.
Yeah.
It's the only way.
Because it's the only one that integrates with YouTube.
It integrates, because of the integration. Yeah, I want to set that up. Yeah.
Okay, there we go. I've created our very basic board. And now we can just come in and we can draw some wires. So I can go here, auto routing, and it'll say, what do you want all this sort of stuff done, da-da-da-da-da.
So W5TXS is asking if this will be a daughter board for the K-type connector instead of the DIN board. This particular thing that we're demonstrating how to do right now, no. But we will be doing that. Chris is asking, why not flip the connectors around? Sure. When you get it, you can turn it upside down, Chris.
So here is the wiring that it did with auto routing. Now, all these grounds are on the bottom layer with the blue trace. So you can turn that on and off here, and all the red ones are on the top layer. We could make this a single layer board, and it would probably be cheaper. So we could probably do that later on. But for all intents and purposes, that's what we've got. And if we
all
go
intensive
3D,
purposes.
No,
Right,
he
Jim?
said it. He said it right. Thank God, because I would have
I know.
corrected him if he had.
all
So
intents.
Chris was asking
and
about
purposes.
this. Why not flip the connectors around? Chris, I don't know why we wouldn't want to flip these connectors around. We just haven't gotten that far yet. But we
Seems
got to
totally
walk before we
legit to
can
me.
run.
But it
Have
was
we-
made
have
in
we-
it's designed in
this-
Australia, so it's backwards.
This is where the 3D view comes in handy. Our DIN
course.
connectors are backwards.
And we haven't even confirmed the spacing and the orientation on the 2.5 connectors, 2.5, 3.5 connectors.
Right. Well, see, we don't need to worry about that on here because these aren't plugging directly into the AISC because they're jacks. They're not plugs. So what we could do is we could redesign this and swap these out for the plugs with the correct spacing so that you would just plug this in with a cable straight away.
We could
That
certainly
makes
do
sense.
that.
Yeah. But again, we're not making this. Do you actually want us to make this? If you want us to make this, then we'll do a proper job of it.
Yeah, put it in the chat if you want it.
Yeah. Put
But
a plus one in.
the plan is to make a DI6 style, but a DIK board. So it's going to have the trim pots on it for your audio levels. It's going to have the 1200, 9600 switch if you have a radio that you've modified to do 9600 inputs, outputs. You know, like this is just showing y'all how to use the software.
There we go. So now if we go 3D, we should have flipped that connector around. There we go. So this is just a very base. This is like a breakout board, basically.
Exactly.
Yeah.
So this will come straight through cable from our daughter board
DI6. Yep.
straight into the K connector. And then you'd use just normal 3.5mm cables directly into your radio from here. There's no ones in the chat, so I guess no one wants this board. So,
Well,
Well-
W5TXX said do a proper job.
Yeah. So we got one vote out of 72
One
people
vote.
watching.
Well, I think
So-
you have two because he also it's the same guy.
so the proper
Yeah.
proper job is basically going to be this, but with the connectors swapped out on the front.
Yeah, and I just think that there's not enough room to do proper spacing on the board to do two sockets that are actual K connector specific spacing.
The other issue too is that if you can put cables, so like sockets that go directly, if you could fit them directly to the handheld from here, but you wouldn't be able to put plugs on there and then plug this into the side of your handheld because it would be
No,
too
it'd be
big
too
and
much.
too janky. Yeah.
Yeah, and the USB-C is on the wrong side unless it's far enough away.
Yeah. Yeah. So you'd have to just put sockets on here as well.
Yeah. Like, I mean, this would be designed to be like in your go bag next to it.
We got a -1, so that cancels
So-
out the +1.
Yeah. Net zero. So W5TXX, take a look at the board on the screen now. Not that one. Go back to the
Oops,
other one.
Sorry.
Take a look at the board on the screen now. This one. And instead of having the 6-pin connector, it will just have the 2.5mm and 3.5mm sockets. And then we'll get you an Amazon link for the straight through cables.
And then we'd have to eliminate a few things. You won't need this switch here. You won't need this switch
Right.
here. You probably don't need that switch there. There'd be a couple of components we'd have to delete out.
So I'd argue about the 9600, 1200 because the Quanshangs do have a mod that can be done for 9600. So we should be able to support that.
Okay, could leave that in. Yep.
John is asking, can you swap the DIN for K plugs?
Yes, that's what we just went through. Yep.
So 9600, as in the Quanshan, can actually output that.
Yeah.
Yeah, okay.
But
On
you
the
have to
same
open up
audio
the
line?
radio and you have to open up the radio and rewire it internally. You have to do a bodge job
Yeah.
inside the radio. It's a hardware
So we
hack.
don't. So we won't need the switch then, basically, because you only have one audio line coming in.
Ah, that's right. There's no choice. Yeah, you're right. Okay.
Yeah.
And then do you
'Cause
need the LNR?
No, I don't
Uh,
reckon so. I don't think
That
so.
is for switching on the computer side.
Yeah, selecting.
So maybe
when I designed this, I don't even know why I put this here because the CM108 outputs in stereo audio, and you're only using one channel of audio into your radio because your radio doesn't have two microphone inputs, if you know what I mean. So
right.
I don't even know why that was there. It was just put there just because, but yeah.
On the DI side, on the main board, the motherboard, there is a left and right audio channel, but ham radio is only mono. And so if you wired it up on the wrong pin, I think you can flip that switch, right?
Yeah. Yep.
Or if you used a mono cable for some bizarre reason instead of a TRS cable.
Well, the TRS cable on the K connector cables is to support not just audio, though. It's to support PTT and ground and the voltage as well. Yeah,
never mind.
This is the thing is there's like 60 different standards.
Standards. That's kind of like a Boston accent there.
I'll stick to Australia.
Chris is asking if people would be more interested in PCB design, and I think Chris, it'd be a fantastic idea, but you've got to get from people know absolutely nothing and start there, because I don't know anything about this, bare minimum type stuff, and then level your audience up. I mean, you only have to be like one step ahead of your audience in order for it to work. It's a great idea. Do it.
Well, I learned all of this, and if I can learn it, anyone can learn it. So,
Ted, yes.
It just takes a bit of time to.
Depending on which store you order them from. If you order them from the U.S. store, they go clockwise, and if you order them from the Australian store, they go counterclockwise.
They do this.
You're making everybody sick.
I know. All right, I think we've made some sort of progress. Maybe we should just get a couple of these made up and just have a bit of a play, Tio.
Yeah, for sure.
Actually can double check our wiring, because it's probably not a good thing to do on stream.
So with this, I could hook the Toads DI board to like my Yaesu FT1000.
Does an FT1000 have a K connector? I don't know.
No, it doesn't. It doesn't. It has
it's an HF radio.
It's an HF radio.
Yeah, we'll make a 13-pin board somehow. The connector might come off the side instead of off the front.
Yeah. Because
that 13-pin connector is ginormous.
So with this, the whole reasoning behind making this way was because we knew that the 6-pin, there was a lot of radios with the 6 pins. Once you get the 6 pins out of the way, then you start to get into like 13s and 8s and different. And it's like, do you want us to make a board for every single radio? Like, that's going to be a big job. Right. So the K connector is probably the biggest next one
second
that
most
people
popular,
have been asking for. Yeah.
And that makes sense. But so this may be a stupid question because I'm not sure I fully understand everything here. How does this differ from something like a DigiRig, where all the magic is basically it's basically the same box with a couple of exceptions, but just different cables. It's the same connectors at the box on the box side.
Yeah. So the main difference is that we're trying to educate and learn people up, get people to tinker and experiment and play and that kind of thing. And the DigiRig is an operator, appliance operator type thing. Dennis is awesome. Dennis has done a fantastic job on that product. Every time I think that the DigiRig can't do it, I find some documentation where I open the case up and cut a trace and add a solder pad connection and magic
I've done
happens.
Yeah.
And it's a great product. And if you want something that is, plug and play and he's got a radio, so he's got support for the radio that you have.
Well, I didn't mean that in a confrontational way.
Oh, no, not at all. Not at all. Dennis is awesome. Simon is awesome. The AIOC is awesome. All of this stuff is great.
You're awesome, T.O. You're awesome.
Thank you. You're awesome.
And I think as far as I mean, I might be wrong, but I don't think the DigiRig works with All-Star natively with the CM108, because All-Star's this real thing where it's like it wants this one chip and then that's what it wants for the simple USB channel drivers. Okay. I'm sure you could get the DigiRig to work, but yeah, and Direwolf's the same.
You may be right. I thought I did Direwolf with a DigiRig.
Probably
You
could.
can.
Okay.
I think the DigiRig's missing the COS line, isn't it?
Yeah,
that may be. I don't remember. I worked on my Digipeater iGate box with a Yaesu FTM 1500, which is a 2-meter tiny little radio I got for like $25.
Mm-hmm. I've got one in the box behind me.
You do.
And
Go ahead.
it's probably a good thing to go back to, because the whole premise of why the actual Toads digital interface started was to stop this, because
Right.
TO tried to do this and tried to modify a cheap USB sound card, and it was just it's too hard. These pins are too small. I mean, I've done a couple of them and I've busted a couple doing it as well.
It's easier to get it wrong than it is to get it right. And
Yeah,
this is ham radio. We're ham radio operators. We have access to technology, and we can improve beyond year 2000, like this website. I'm sure that's when this website was actually first made. I'm not discrediting this person at all. Like, they did a fantastic job, but this person stopped doing it, and it's time to pick up the torch and keep moving forward.
So essentially what we did was we just created an interface, which is this already done. So you don't have to modify anything. It's just done, and it's made, and it's ready to go. You can do this by all means. Have a go.
Mm-hmm.
So, and I've got a couple of these that are still running, working well. So, yeah. Anyway, hopefully that sort of helped out. Anything else we want to cover before we?
I think
I am sold out. They got to get it at Hayden's store.
Yeah, so Australia, New Zealand. I don't know if I think I've got about 8 or 9 left in stock. So if anyone wants those, I've also got the AIOCs, and you're going to have some AIOCs soon as well.
Eventually, yeah. So what was it, like Wednesday? I ordered a refresh. Hayden, you were helping me. So I ordered 100 more boards, so they'll be here like next week or so. And Craig did a video on them. Craig KM6LYW did a video on them, and that helped do some sellout stuff. And then there was one other thing that happened a couple days ago. Matt did one.
Yep. And then there was someone else as well. So, and I've had a couple of people who have been getting them too, and they've been making up some all-star nodes with them. A couple made some APRS digis as well. One guy said that it's great because he had that very problem where he was trying to modify the little boards, and then you'd have to ship them off over to, like, he was making a full node, and then he was shipping it off, and then in the transport process the board would get broken, or the wire that he soldered on would come off, and then it would break, and they'd have to send it back. And now he's like, at least it's all made up, and I just need to plug it in, and then that's it. So yeah, thanks for joining me, lads.
Yeah, and this is the beginning of a new month, so you can drop in your membership milestone super chats now if you want to get it off early. Because I'm not sure, Hayden, when the next time is that you're going to be doing this live stream.
No, I don't know. I don't know either. It should be good for next week, so we'll see how we go. But
LC, no back orders on my site for these products, but it'll be replenished pretty soon.
Yeah. Do you have a thing where you can sign up to get updates on your site? I think you do.
Maybe. I just don't send out updates. I got way too much stuff going on.
Here it is.
Yeah, at the bottom. Join the club. Email address. Get exclusive deals and early access to new products at the bottom
down
of the website.
Here. If you put in your email address here down the bottom, then you can get access to when they're back in stock.
And T.O. just won't even email you.
Nah. You're just.
I got to make shorts. I got to do live streams. I got to do long form videos.
You're
it's a whole
busy.
job, man.
You're busy.
Yeah. And honestly, if it weren't for all the administrative BS on the back end, like if I could afford to hire somebody to help out with that, I could put out more than 3 videos a week.
Okay. Calm
you
down.
need
it's crazy.
You
need a personal. You need a PA. That's what you need.
PA. Well, if he could afford me, I'd be his PA, but
you'd be his bitch.
You're right.
Let's call it a PA. Okay.
PA bitch.
All right.
There's just that much stuff to do in ham radio.
I know. On that note, I think 2.0 is streaming. He's been doing his ham radio in 30 days. He's been doing a video per day. So go over and see 2.0, and we'll see you next week.
He is doing a fundraiser tonight for the ARRL Teachers Institute.